Alright everyone, welcome to another episode of µCast. Today we're talking capacitors. I don't want to do a full episode on them, I just want to give a brief introduction to what they are, why we might use them. So the first thing I want to show you is the schematic symbol, so that when we draw these in a circuit you'll know there's two different ways that you really see these represented. One is with these two plates here. Sometimes you'll see it with the curve and the straight. That indicates positive and negative. That indicates a polarized capacitor. What is a capacitor? The very simplest way to think of a capacitor is that it stores charge. It's like a reserve tank. That might be an oversimplification, but for our purposes, that's good enough. So let's take a look at a few of these down here on the table. They come in all different shapes and sizes. This is a small one. They come in much smaller than this. You can see they get bigger. This is kind of a fatty.
Ooh, so thick. Now I know what to call it, a fatty.
And this is a different kind. These are electrolytic. This is a tantalum. Don't worry about what that means. Not important. There's different kinds of capacitors. We use different kinds for different scenarios. When that's important to know, we'll let you know. The two important numbers on a capacitor are right here that you can see on this one. It's got a capacitance, which is measured in this case in microfarads, and a voltage rating. Now, this also is different in that it is a polarized. That's what this little signal here is. This shows you this is the negative lead and this is the positive lead. Okay, so there's three important things that you need to know about a capacitor. One, is it polarized? Because if it is, you have to hook it up a certain way. There'll be indicators on it to know which side's the negative, which side's the positive. That's the first thing. The second is, like I said, the capacitance. This is a 3300 microfarad capacitor. That's how much charge it can hold. This guy right here, 1 microfarad. You can see the difference in size. This holds a lot more charge than this. The third thing is the voltage. This one's 50 volts, rated for 50 volts. That means you can apply a voltage anywhere up to 50 volts on this. If you go over that, same thing as if on a polarized, if you hook it up backwards, if you over voltage this, bad things are going to happen. Dogs and cats living together, mass hysteria. No, it's not that bad. But you could set something on fire, no joke. So don't exceed the voltage rating. Now, so let's see one of these in action. Let's come down here to the circuit that we have looked at before. We've got our 9-volt battery coming in. It's going through an LED. We figured out the value of this in our LED episode. And it comes into a LED. So when we hook this up, the LED turns on. Now, as soon as I disconnect the power, LED goes right off. So like I said, a very simplified way to think of a capacitor is like a storage tank. So we're going to hook this up. Remember, our green is our negative side, our black is our positive. So we want to make sure we're hooking this thing up right. So we're going to put this here and this here. And if I don't bend the legs... Okay, I think I've got that in there good enough. Okay, so now let's hook this up. Have it light up. We'll go ahead and let the battery charge up that capacitor. Like I said, think of it kind of like as a storage tank. And now I'm going to disconnect the power and we will watch what happens. You can see the LED is sort of kind of dimming. It's now taking its power, its charge, its voltage from the capacitor. You can see that. That'll dim out. It'll actually stay very dimly lit for quite a while. So again, kind of a simplification. That's really what we're going to use capacitors mostly for, is to hold charge that we can use. So I just want to real quick show you how that would be useful. A real-world application of that is when you have a power supply. We say we want to supply, this is 0 volts, this is 9 volts. And we want to supply 9 volts to our circuit. That's what it should look like. It should look like 9 volts always. This is time as you go along in time. It'll always supply 9 volts. Now if you think about in your house, when you plug in your vacuum and you turn it on, what happens? The lights dim. So it's not 9 volts, depending on if you're in America or otherwise, you're like at 120 or 210 volts. But what happens is when you turn on that vacuum cleaner, there's a voltage drop, and then it kind of comes back up. And so it kind of steals power from your circuit. That's a very simple way to think of it. So where you get this dip. Well, what we use a capacitor for is a reserve. So in times like this, the capacitor can say, you're not providing everything right now, I'll go ahead and step in to keep that nice and smooth. So what we're mainly going to use capacitors for are for smoothing power supplies. Power supplies can be noisy for lots of reasons. Noise on your mains line, things in your circuit are causing voltage drops. So instead of seeing a nice 9 volts, you might see something that's kind of ripply like this, whatever. You stick a capacitor on that, it fills in these gaps and helps you create a nice smooth line like that. That's mainly what we use them for. There are a lot of things that you can do with capacitors. You can create filter circuits, resonant circuits. We're not going to worry about those. Right now, I just want you to know there's symbols, so when we use them in a schematic, you know what we're talking about, and it stores charge. For now, don't worry about that. Don't worry about more than that. Just know there's a capacitance value, there's a voltage value you don't want to exceed, and sometimes there's a polarity to hook it up right or wrong. Make sure you hook it up the right way. If you have any other questions, let me know. Leave them down below. I'll put some links for some good resources if you want to learn more about them on your own. That's it for now. See you next time on µCast. Okay, see it out. Okay, one more thing I forgot to mention, and this is important. Capacitors store charge, like we said. They will keep that charge for a really long time. So when you're messing around with these things, you need to be careful. And this is what I'm talking about. If we want to come back down to the circuit here real quick. I'm going to hook this back up. I'm going to charge this capacitor up. So this now is storing the charge from the 9 volt. And now I'm going to disconnect it. And now I'm going to pull this out. This thing still has charge in it, and you need to be careful with these because if you put a lot of voltage on these will hurt you. They can kill you if it's a big enough one and it's got enough voltage on it. It's not something that you want to mess around with. And it will keep that charge on there for a long time. That's why on TVs and things you see, don't open them up because it's dangerous, because those have some big capacitors in them that if you touch and they're charged, not good. So just to show you that real quick, let's come down here to our meter. And I'm just going to hook this up on this lead. That's the, just do it like this, the negative and the positive. You see, it discharged a bit there from when I removed it. Now, if I hadn't let the LED discharge there, that would still have a full 9 volts on it. But you can see that still has 3.7 volts on it. Fully charged, it would have 9 volts on it. Now, this is kind of a more advanced topic, and it gets down to the physics level of this, but if you remember, you stick that 9 volt to your tongue and you get a little tingle. When this has 9 volts on it, that's not going to be like a 9 volt. The 9 volt can only deliver so much current so fast to your tongue, and that's where you get the tingle from. This thing can unleash everything all at once. It will hurt you. Don't mess around. Don't charge this to 9 volts and then touch it to your tongue or then go touch other people with it. Don't mess around with these. Now, a way to discharge these with low voltage, I wouldn't recommend this with a higher voltage. We're mainly going to be dealing with low voltage. An easy way to do this, take a screwdriver or something metal like this, and you can discharge it by putting these across. Now, if there's enough voltage, you might get some sparks, but this is a good way. You hold this on here, you let it just get all that charge out. Then we come back down here, measure it again. You can see now we're down to 0.35, and you know, if you held that on there long enough, it would discharge completely. You'd be down around 0 volts. Anyway, just wanted to let you know, these can be dangerous. Don't mess around with them. We're not going to be using even things this big. This is for a different project. Mostly we're going to be using tiny ones that even if you had pulled out and touched, you'll be okay. But just something to know, charge will stay in these things. It will stay for a long time. Make sure you're careful. Thanks.